Talk about a lot of the science that the crew members on board the International Space Station are busy with today. There's a lot of new science experiment hardware on its way on board the Cygnus vehicle. I'm going to learn more about that, some of it anyway, this morning. Dr. Liz Warren with the International Space Station Program Science Office joining me. Thank you.
Absolutely. Pleasure to be here.
We'd like to talk about numbers a lot. There's 5,000 pounds of cargo on board that Cygnus, and some 1,600 pounds of it is science cargo.
Yes.
What does that really entail? What makes up that 1,600 pounds?
Well, that's roughly a third of the pressurized volume of that spacecraft is dedicated for science utilization. A lot of it is resupply for some experiments that use what we call consumables. That's materials that are used and then later thrown away. And a lot of it is actually some new experiments that are going up.
Well, we'll talk about a few of them. There's one human research experiment that I found interesting when I talked to Samantha Cristoforetti about, just because of the name of it. It's called Drain Brain. What's going on here?
Well, it's kind of a fun name, but it's a really interesting science investigation. As you mentioned, it's about human research. And specifically, it studies the physiology of the cardiovascular system.
And that's why she's ultrasounding herself.
Yes. So in the shot you're seeing right now, Samantha Cristoforetti is using an ultrasound probe to measure the diameter and flow of one of her blood vessels in her neck. Now, on Earth, our cardiovascular system, our heart, pumps blood up to our brain, up to our head, and then it flows down normally, thanks due in part to gravity. Now, when an astronaut is in space, there's no longer any gravity to basically help drain the brain. So there's no longer a gravitational force that is pulling that fluid back down. It does return to the heart, but we're not exactly sure all of the mechanisms that are at play, and we're not exactly sure how everything is working. And we have had some astronauts report symptoms such as headaches and some other neurological issues that lead us to believe this is something we want to learn more about. And so this investigation uses the ultrasound, uses the pulmonary function system, part of the Human Research Facility rack, and also a new piece of hardware, which is called a strain gauge plethysmograph. And what that does,
plethysmograph.
Actually, it's plethysmograph. And what that does is it measures very precisely the circumference of the astronaut's neck. And it's really based on how much it stretches. And that will help us understand the fluids and how they're moving in and out of the head. And that will hopefully lead us to understand a little bit more about venous return to the heart, help us understand the cardiovascular system function in space.
It's a good example of things that we take for granted that we can't when you go to this environment.
Exactly. So this will be very interesting.
There's another interesting piece of hardware flying on this Cygnus for an Earth and space science experiment called Meteor. Tell me about that.
So Meteor is the first space-based observation of meteorites that are entering our Earth's atmosphere. And you can see a picture there that was captured by Ron Guerin during his increment. In the middle of the shot, there's a little streak of light, and that is actually, he happened to get a really lucky shot. That's a meteorite returning or coming back to Earth and burning up in the atmosphere. Now, our Earth,
I can correct direct television from here and zoom in. You'll see that little streak is bigger, and you get it looks kind of meteor-ish.
And our Earth is constantly bombarded by bits of debris. Most of it burns up in the atmosphere, so it's totally harmless. But this is the first space-based observation where we're going to be able to determine the composition, the size, and the density of those meteorites. So there's a camera that will be mounted in the Wharf observational rack. That's the window observational rack in the Destiny module.
That's in the window that's looking down to Earth.
Yes, this window faces the Earth, allows the camera great access to our atmosphere. It's a beautifully optically clear window. And what you're seeing right now is actually practice on the ground before it goes, of course, up to space on the Cygnus.
That camera looking through that port down to Earth.
Correct. And so the scientists will be able to study the spectrograph, which is an analysis of the types of light that are being emitted by the meteorites as they come back through the atmosphere. And by studying the quality and the wavelength of the light they will be able to determine, as I mentioned, the density and the composition of those meteorites. For example, how much iron or magnesium or sodium is in those meteorites. Now, what that will give us is some insight into where those meteorites came from. Generally, during a meteor shower, we know the origin of meteorites entering the atmosphere, whether it's from an asteroid or a comet that is coming close to Earth. And so by understanding the composition of those meteorites, that gives us some insight into the composition of the parent systems, if you will, and can help us understand more about the universe around us.
Does that have to operate all the time because you don't always know when meteorites are coming?
Exactly. So that shot earlier, Ron Guerin just happened to catch that was a lucky shot, really. But this is going to be operating on and off for long durations, and particularly during known meteor showers, but also it'll be operating other times as well. We may even discover some new meteor showers.
Cygnus is also carrying up more than a dozen experiments from students of a variety of ages. Tell me about this Student Spaceflight Experiment Program.
Well, the Student Spaceflight Experiment Program, or SSEP, is a wonderful STEM program, STEM, science, technology, engineering, and math. And as you mentioned, students from grade 4 all the way through college have an opportunity to fly an experiment to the International Space Station. Can you imagine having
no.
to be? Neither can I. How cool that would have been. So this is a great opportunity to inspire students to get interested in science and math. They propose the experiment, they ask a question, form a hypothesis, just like scientists at universities and academia. And their experiment is chosen through a selection process and gets loaded onto these Cygnus vehicles. And this is, I believe, the sixth example, or the sixth spaceflight opportunity that SSEP has had. And of course, it's a program that is due in partnership to CASIS, which is the Center for the Advancement of Science and Space, NanoRacks, and the National Center for Earth and Space Science Education. And these experiments range in topic from plant growth and gravitropism to some bacterial activity, even a composting efficacy experiment, and an interesting one about tin whisker formation in soldering. This is applicable to circuit board production here on Earth. The tin whiskers can be a little bit of a problem, so these students are asking, well, if we do this in weightlessness, is there an advantage? So really interesting experiments, great program, and I sure wish that if somebody was around when I was in high school, I would have loved to have done that.
It's all very exciting. We'll see them coming up on Cygnus, launching later today. Liz Warren, thanks very much.
Absolutely. Thanks, Pat.
Dr. Liz Warren is with the International Space Station Program Science Office.